We have this basic problem in analytical geometry, which is the following. We want to find the intersection points between this curve, which is a unit circle centered at the origin, and the parabola x squared. So in order to solve this problem, it's good to draw a Cartesian coordinate system. Here is the unit circle with so the radius is 1. It's 1 here, -1, -1, and 1. And the parabola is like this. So visually we see that we have two intersection points here. And basically, in order to find this intersection point, we need to solve this system. It's not a linear system because we have x squared here. We have to solve this system. So between the unit circle and the parabola, what we can do here is substitute y equals x squared to the first equation. So we have x squared plus y equals x squared equals 1. So it's x to the 4th power plus x squared minus 1 is equal to 0. This is a biquadratic equation. We set w to be x squared, so we have w squared plus w minus 1 is equal to 0. This is a quadratic equation, and the variable is w. We have w squared plus w minus 1 is equal to 0. We find the discriminant, 1 squared plus 4, the discriminant. So from here, w1 is minus 1 plus square root of 5 divided by 2. And w2 equals minus 1 minus square root of 5 divided by 2. I can write w1 as square root of 5 minus 1 divided by 2. And w2 equals minus square root of 5 plus 1 divided by 2. But I have to switch back to my original variable, which is x. X squared equals y1. X squared equals square root of 5 minus 1 divided by 2. So I can write it as x squared minus the square root of 5 minus 1 divided by 2 squared. And from here I get x equals square root of 5 minus 1 divided by 2 minus square root of 5 minus 1 divided by 2. I have two solutions for x. x1 equals square root of the square root of 5 minus 1 divided by 2, and x2 equals minus square root of 5 minus 1 divided by 2. If I want to find the y coordinates, what I have to do is substitute back to parabola. So if for x1, y equals x1 squared, which means I have this quantity squared equals square root of 5 minus 1 divided by 2. And for x2, y equals x2 squared. Now I have this quantity with a minus, and what I get is square root of 5 minus 1 divided by 2. Basically, what I have is two intersection points. A is the following. Square root of 5 minus 1 divided by 2, the square root of this, and the y coordinate is just this one squared. This point is in the first quadrant of the Cartesian coordinate system. And B, the other point, is minus square root of 5 minus 1 divided by 2, square root of 5 minus 1 divided by 2, and this is located in the second quadrant. Now let's go back to the graphs. So here I have A coordinate, and here I have B. And this is the first quadrant of my Cartesian coordinate system. And B in the second quadrant. Because of course the x is negative here, and of course y is positive. Here the x is positive, here the x is negative. Consequently, I have two intersection points between the unit circle and the parabola. Circle, and this is parabola. This is my parabola, and this is my unit circle.